To explain the Sn1, Sn2 energy diagrams a little bit better, I'm going to try and show you two animations, and I'm going to show you two pictures that explain these animations and what's going on. Now, first of all, I want to point out we've got an Sn2 animation here, and this is an energy profile of this reaction. So at the beginning, we're starting at this point, which is the energy of this compound right here, and the Br minus that's going to come in to attack it. You don't see the Br minus yet, and it'll turn up in a second. Now what's going to happen is that in one step, the Br will attack this C and the Cl will leave, and you'll see the changes in energy as this occurs, and I'll try and stop it at the various points so you can see those changes. Alright, I'll stop it there. Now take a look. As the Br minus is approaching the C, it's not quite there yet, but as it's approaching, the energy of the system increases because you've got a very close approach of the Br minus to this C right here. At this point, the Br and the Cl are simultaneously joined to this C. These bonds are not full bonds; they're partial bonds. The Br is attached and the Cl is attached at the very same time. This is very high energy, and the reason you would know this is high energy is because you've got a carbon here that effectively has 5 bonds attached to it. Then as the Cl leaves and the Cl moves away, then the energy goes down to what we have here, and that's the product. Alright, so that's for Sn2. That's a one-step process. Let's take a look at Sn1, which is a two-step process, and you'll get an appreciation for what's going on here. Alright, so in Sn1, what's going to happen is that the Cl will actually detach first from the C. And initially it would started down here, and then as the Cl is leaving, Cl is just detaching all by itself, we get to the highest energy point here, and this is the point where the Cl is just about to leave. The Cl is just about to hit the road. After the Cl leaves, what we're left with is a Cl negative and this carbocation here, which is planar. This business here is supposed to be a p orbital, but this carbocation is planar, it's flat, and it will allow now for the attack of the nucleophile to come in. This was different to the Sn2 reaction where everything happened in one step. This happens with the formation of the carbocation first, followed by the addition of the nucleophile. And the point being made here is that this nucleophile, which is water, can come in and attack from either side of this carbocation. Right, at this point, what's happened is that the O and the C are just about joined. They're not quite joined, but they're just about to join, and that's the peak of this part of it here. Now what's happened is that the O has completely joined onto the C, and we've got our product. Don't worry about the rest of this, it'll just form the product that we're going to get at the end, which are these two, which happen to be enantiomers. Alright, let's take a little bit more of an in-depth analysis of each of these. We'll look first of all at the Sn2 reaction. I know this looks like a real mess, but really this does a good job of explaining it. Alright, so we're starting out with our reactants, which are the four carbon chain with the Br on it reacting with the Cn-, and that's going to start here and have this energy. Now as this bromide and the Cn- approach, and that's why I've got these arrows here because they're approaching, the energy of the system increases. Now that they're really close together, it's increasing further still. At this point, the Br and the Cn are simultaneously attached to this C. That's the highest energy point of this process. Then as the Cn attaches and the Br leaves, and they are moving further apart, then the energy begins to decrease again until we get to where they're really far apart and energy is quite low down here, and then we get down here to the products. So all of this happened in one step. So it's one hump, it's one step. So that's an Sn2 reaction. Alright, let's take a look at an Sn1 reaction. The Sn1 reaction is a two-step process where the Br leaves first, forms this carbocation, and then the Cn comes in and attaches. In the previous example, you saw that all of this happened in one step, where the Cn and the Br were joined simultaneously to this carbon atom. That doesn't happen in the Sn1 reaction. What happens is the Br leaves. Now, as the Br bond, the Cbr bond gets longer and longer, the energy of this system increases until at this point, this is when the Br is just about to leave, and that's the highest energy point of this system. Now the Br has left, and we're left with a C plus and a Br minus, and they're moving further apart. So the energy is going down again until we've got this carbocation and the Br minus far apart. Now at this point there's also a Cn minus in the picture, and the Cn will join to that positive charge. At this point here, the Cn is just about to join to the C, and here is just joining onto the C, and now the Cn is just about to join to the C. That's the top of this little peak down here. Now down here the Cn and the C are almost bonded, and now they're completely bonded. And that's the end of the Sn1 process right there. Now if you look at the different changes in energy, you can see that for this one, the activation energy for the reaction will be right here. So this is the amount of energy we need to put in order to get that Cbr bond to break. Now there's also an activation energy here as well, but it's only tiny. And that is the negative, this negative here from the Cn being attracted to the positive. So that's a very low energy process. This Cbr breaking is a very high energy process.